Okay, hello guys, welcome back to the channel. In today's lesson we're going to be doing revision for algebra for your June exam. Please make sure you tune in this channel every day. I'll be posting revision videos. So in today's lesson we're just going to be focusing on the algebra part, and then the following day I'll be posting on functions and then so on. Okay, so 1.1 says solve for x in each of the following. We have 1.1.1. We are given this equation here for 2 marks. We're given x, 2x plus 1 is equals to 0. Now we know with this one it's easy peasy. First you check, you can see that this is in standard form. We have equal to 0 here. That means you just take everything in here and equate it to 0. So you'll take this x, equate it to 0, and then say or 2x plus 1 is equals to 0. So you already have one x value here. Then let's find the second one. We have 2x. When we transpose that positive 1, it becomes negative 1, and then divide both sides by 2. So we have x is equals to 1 over 2. So that's 2 marks for those values, right? Then in 1.1.2, we are given 5x squared plus 2x minus 6 is equals to 0. And then we can see this hint here, correct to 2 decimal places. Every time you see correct to 2 decimal places, then you know you have to use quadratic equation. Right, so now I'll start by saying my A is 5, and then my B is positive 2, and then C is negative 6. Then I can write my equation. X is equal to negative B plus minus B squared minus 4AC over 2A, right? And then what is my B? The B is 2, and then I have plus minus. And then what's my B there? It's 2, and then I say 2 square minus 4, and then A is 5, and then C is negative 6. And then all that over 2 times 5. Now it's just a matter of punching in your calculator and then finding your answer there. So we have x is equals to 0.91. Or x is equals to negative 1.31. Nice. And then, okay, so now let's try to solve 1.1.3. So here we are given an inequality, and then we can see the first thing we would do with this inequality is to take this 3x and transpose it to the left-hand side. So we have 2x squared minus 3x minus 2 greater or equal to 0, right? Then we try to factorize this one. When we factorize, it becomes 2x plus 1, and then x minus 2 greater or equal to 0. Now at this point you don't want to solve it as you would an equation, so you need to understand that now you are working with an inequality. Then you just, by the side here, try to solve it as if it was an equation, but then you don't show it on your calculation here. So this is 2x plus 1 is equals to 0. Then your x for this one will be negative half. And then for the other one, we have x minus 2 equal to 0. Then x is equals to 2. Now what you're supposed to do for this one is just come here and say critical values, and then give us your solutions. So it's negative half and 2. So starting from the minimum value to the maximum value. Now at this point you want to test if you want to test for what values will your inequality be true. Is it for values that are within your critical values or for values that are outside your critical values? Now if the values are within your critical values, we know this is the sign that you will use. So your minimum value will go in here and your maximum value will go in here. But however, if you try to test with the values and then you find that the values that are within the critical values do not satisfy this equation, then that means it should be like this. So your inequalities should now face opposite directions, right? So now let's test. Now, the method that I use for this one, if I have a negative value and a positive value, is what I call the zero tester method. So basically, I just test with 0 because it is in between. So you have a negative answer and a positive answer. Then we know the value that is between that, it's 0, and then 0 is much easier to test with, because you know if you just substitute in 0 here, it will just give you the value in here, which is your constant. So now let's do it. Substituting 0 here and 0 here, our solution will be -2. Now we ask ourselves, does it satisfy the equation or it doesn't satisfy the equation? Remember, if it satisfies the equation, then it's this one. If it doesn't satisfy, then we use this notation. Right. Now, is -2 greater than 0? So we know that -2 is less than 0, so it doesn't satisfy the equation. So now testing with values that are in between your critical values gives you a negative answer. And what are we looking for in order for this inequality to be true? We are looking for a positive answer, right? Now, you might ask yourself, how do you know that it's values that are outside the critical values when you haven't even tested with 1? So let's test with 1 value, right? So let's test with 3 maybe, because we can see 3 is outside these critical values, right? So take this inequality or expression, then where there's x, put 3. Now, if you can just punch all this in your calculator, you have 18 here, you have 9, and then you have -2. This one will give you 7, right? Now, we know 7 is greater than 0. So that means for values that are outside the critical values, this inequality is satisfied or is true, right? Then, therefore, now we will write x less than the minimum value, which is -0.5, or x greater than 2, which is the maximum value. But then remember, our inequality is greater or equal to 0. So we need to come here and say x must be less than or equal to -0.5, or x must be greater or equal to 2. Remember, they also wanted this inequality to be equal to 0. So when we put in our critical values, they will give us 0 for this equation here. So now, those are our values, and then representing it graphically, if these arrows are facing opposite directions, then we have to indicate our critical values in here, and then shade these parts here to indicate that our values are outside the critical values. And then we can just make here darker, just to indicate that also -0.5 and 2 are part of the solutions. Okay. Now, coming to 1.1.4, we are given root 2x plus 1 minus 3 over root 2x plus 5, and then is equals to -2. Now, at this point, we can see that this is in square roots, and then we can also see a fraction, which is a lot of confusion. Now, we have a method that we call the K method, which will come to our rescue when we have something like that. So we can see that it is complicated, and trying to solve this might be a bit of a challenge to most of you. So now we'll just say let root 2x plus 5 is equals to k. So we do this in order to get rid of the 2x plus 5 and then express it with a letter that we can all understand. And then since we know that we'll be dealing with just one variable here, it will probably be much easier to deal with, right? Then at this point, we can just take this k and transpose it to the other side. So we have -3 over k is equals to -2 minus k. Now, in order to make this a positive, let's just multiply both sides by -1. So we have 3 over k is equals to 2 plus k. So when I do this mathematically, I haven't changed anything, because remember, what I did on the left, I also did on the right. Then at this point, let's write this in terms of a fraction so that we can cross multiply here. So we have k times 2, 2k, and then k times k plus k squared. Then what is 1 times 3 is equal to 3. Then we can just solve this, take this 3, transpose it to the left hand side. In standard form, we have k squared plus 2k minus 3 is equals to 0. Then let's try to factorize this. We have k minus plus 3, and then k minus 1. So yeah, hopefully I factorized well. 3 times -1 is -3, yes, and then 3 minus 1 is 2, so it's good. Then at this point we know we have to equate each bracket to 0. So let's just fast forward to k is equals to -3 or k is equals to 1. Right. Now at this point we need to remind ourselves that the solution that we are trying to get here is not k. Remember, we are solving for x. So do not be carried away in this k method. You need to then remind yourself that we are not solving for k but for x. So you need to say, but k is equals to root 2x plus 5. Right. Remember, you changed it. You said let root 2x plus 5 be k. Now you need to come and remind yourself that k is that. Now to solve for k, for this one, we can see that if we now have root 2x plus 5 is equals to -3. At this point, we can say this one, there are no solutions for this one. Why? Because when you start to put something inside of a square root, you expect to have a positive answer. So for the fact that we have a negative answer here, negative value, then that means this is not true, right? So we say no solution for this one. Or you can just come here and cancel off that one, or you just say no solution. Then let's try with this one. Here we have a positive, so yeah, that one would work. So we have root 2x plus 5 is equals to 1. And then remember to get rid of the square. So you can see now that the k method really came to our rescue, because now we are dealing with this alone, right? So if you square both sides, here you'll only have 2x plus 5 is equals to 1. Then you can take this 5, transpose it to the right hand side. Then we have 1 minus 5, that's -4. Then divide both sides by 2. So we have x is equal to -2. Nice. Okay, so let's check 1.2. It says solve for x and y simultaneously. And then we are given our equations. It's y plus x is equals to 2. And then we'll say this is equation 1. And then we have x squared plus 3xy plus 8 is equals to 0. And this is our equation number 2, right? Now, we know with simultaneous equations, we always want to choose the equation that is the simplest. So we want to work with the simplest equation. Now, we can see comparing equation 1 and 2, we can all agree that equation 1 is the simplest, right? It is straightforward. So here from this one, we will try to make one of these variables the subject of the formula. Now you have to be smart about this. If you can check here, you see that here you have x squared plus 3x and then y plus 8. Now you can see that it would be best to make y the subject of the formula, because you only have one y variable here. As opposed to making x the subject of the formula, you'll have to substitute it here and also substitute it there. So it's best to make the one that will not complicate you. So let's take equation number 1 and make y the subject of the formula. So we have y is equals to 2 minus x, and then we'll call this our equation number 3. Right, now remember, we must take our equation number 3 and substitute it to the equation we haven't used yet, so which is equation number 2. We need to tell the markers what we are doing. So we say substitute equation 3 into equation number 2. Right, so basically now where I see y, I'll be putting in this expression. So this is what this all means. So x squared plus 3x, and then that's my y. I substitute in this expression, and then plus 8 is equal to 0. So now I have x squared, and then multiplying inside with this one, I will have 6x, and then there I have 3x squared, and then plus 8 is equal to 0. Now we can see that we are working with like terms here. So we have x squared minus 3x squared. That's going to give us -2x squared. And then plus 6x plus 8 is equals to 0. Now we can see that all these numbers are divisible by 2. So we can just divide all of them by -2. What you do on the left, you also do on the right. So if we divide everything by -2, we have x squared. Why are we dividing by negative? Because we want this part here to be positive. Then minus 3x, and then minus 4 is equal to 0. So we know 0 divided by any number is 0. Now when we factorize this, it becomes x minus 4 and then x plus 1, right? And then equal to 0. So our solutions for x will be x is equal to 4 or x is equal to negative 1, right? Now that we have two values for x, that means we must also have two values for y. So now substituting this x values, we will substitute this x values where? On this equation, which is in standard form. So we can see y here is the subject of the formula, so it will be easier to get our y here because we just substitute in x. So we'll say 4. Now we come here, for x is equals to 4. For x is equals to 4, we have y, and then where there is x, now I substitute in 4. So this is 2 minus 4, and then my y is negative 2, right? So in coordinate form, we have 4 is 2 and negative 2, right? Because for the x value of 4, you get a y value of negative 2. Then we go for x is equals to negative 1. Again, in the same equation, equation number 3, this is y is equals to 2 minus negative 1, like that. So we get 2 negative, and negative is positive, so 2 plus 1 is 3. Then in equation form, we have negative 1 is to 3. Because for the x value of negative 1, you get a y value of 3. And that's how you solve your simultaneous equation. So now let's check 1.3. 1.3 says the roots of the equation f of x is equals to 0 are x 4 plus minus root 16 minus 4m in bracket m plus 5 and then over 2m. Now they say determine the values of m for which the roots will be non-real. So we know, revising our nature of roots, we know that roots will be non-real if your discriminant is less than 0, right? So we know that if discriminant is equals to 0, roots are what? Roots are real, and then they're what? They're equal, right? And then if it's greater than 0, we say roots are real, but they're what? They're unequal. And if your discriminant is less than 0, we say these are what? Non-real roots. So we are looking to take the discriminant and equate it to less than 0, right? Then what is our discriminant? You will know that our discriminant is whatever that's inside this square root, right? Because remember, this is x is equals to negative b plus minus b squared minus 4ac over 2a. And our discriminant is always given as b squared minus 4ac, which we can see that these are the contents inside here. So we will take all this, the discriminant. So we say discriminant less than 0. So let's start discriminant less than 0 for non-real roots. So that means we take 16 minus 4m and then negative m plus 5, and then we say less than 0. Now we'll try to calculate m here. So 16 negative 4m times negative m, that's plus 4m squared. Then what is negative 4m multiplied by 5? And that's negative 20m, and then less than 0. Now we can see that all these numbers in here, let's first write them in standard form. So now we can see that all these numbers in here are divisible by 4. So we can just divide everything by 4. And then we will have m squared minus 5m plus 4, and then less than 0, right? Okay, so now factorizing this one, we have m minus 4 and then m minus 1. So because here we have a positive and the middle term is negative, so we have negative 4 times negative 1 is positive 4, but minus 4 minus 1 is negative 5, and then less than 0. Now at this point, remember, we are working with an inequality, so we have to say critical values is what? Is 1. So our critical values is 1 and 4. Now we want to test if this equation will be true for values that are within the values here or outside the values. So now let's test with maybe a number that is outside. So what is a number that is outside? It's 0. So if we put in 0 here, this is 0, and then that's 0. We have plus 4. So our solution will be positive 4. Now is 4 less than 0? 4 is not less than 0, so that means an equation that will satisfy here would be for values that are within 1 and 4. Now we can try to test with a value that's inside here. We can try to test with 2, for example. So 2 here, and then we have 5, and then we have 2 here, plus 4. So remember, if it gives us a negative, because less than 0 means negative, if it gives us a negative, that means the equation is satisfied. Then what is 2 squared? That's 4. And then 5 times 2, that's negative 10 plus 4. Then 4 minus 10 give us negative 6 plus 4. Negative 6 plus 4, that's negative 2. So we can see that for values that are within the critical values, we have this equation being satisfied. So remember, if it satisfies, you write this. So this is minimum value is 1. So we have m here, not x. So this is m, and then minimum value here, maximum value here. Okay, so now let's look at 1.4. This one says show that the maximum value of root negative x squared plus 4x plus 12 is 4, right? Now with this one can be a bit tricky, but then one thing you need to understand is that whatever that we have inside the square root here is in quadratic form, right? So this is quadratic form, and then we know a quadratic form follows has a parabolic nature, right? So this is an equation of a parabola in a way, because the equation of a parabola, we know it is ax squared plus bx plus c. Now you need to ask yourself, if you wanted the maximum value of a parabola, what would you do? Now we know that's like calculating the y-coordinate of the turning point, which we know in order to get the y-coordinate of the turning point, we first need the x-coordinate of the turning point. So this is what you are going to do here. This is a parabola, and then you just say your a is -1, your b is 4, and then your c is 12. So now let's try to calculate the coordinates of the turning points here. So starting by x, we have x is equals to, we know of this formula to calculate the x-coordinate of the turning point, it's negative b over 2a. So what is our b? Is 4, so we have negative, and then we put in our 4, then this is 2, our a is -1, right? So now we have -4 divided by -2, this will give us +2. But then remember, we are not looking for this. This is just the x-coordinate, which will aid in us calculating the y-coordinate. So if we just forget for a while about the square root and just focus on this alone, we would say substitute 2 where there is x. So we have negative and then 2 square plus 4, and then this is 2 plus 12. Then calculating this one, we have here -4 and then plus 8 plus 12. So if we solve this one, -4 plus 8, that's +4, and 4 plus 12 is 16, right? So this is 16. So this would be the maximum value if this was a parabola, right? And then we did not have the square root. But then remember, we have the square root. So whatever our f of x here now, we need to put it inside the square root. So let's say f of x, or let's say g of x now is the same as taking f of x and inserting it inside of the square root. So what is our maximum value? Our maximum value is 16. So we put in 16 inside of the square root, and then we know what is square root of 16? That's 4. So in that way, we have shown that the maximum value for this expression here is equal to 4. Hope that makes sense.